Foundation College. I'm Cora.
I'm Nancy.
I'm Charlie. I'm Melody.
Today we are going to introduce the study of nitrogen dioxide and ozone to all of you.
Air pollutants bring serious health problems to us in our daily life. Nitrogen dioxide and ozone bring different impacts on humans' health through affecting people's respiratory system by intensifying problems such as asthma, reduced lung function. Healthy people may have chest pain, coughing during exercise.
Here is the news which stated the ozone level from Guangdong, Hong Kong, and Macau Air Quality Monitoring Database. Ozone levels record at 13 monitoring stations in Guangdong provinces saw a 6.1% increase between 2010 and 2014, compared to the 9.2% increase record at 3 Hong Kong stations. A chief executive officer of the Clean Air Network said the rise in number of vehicles on the road over the past decade had contributed to the deteriorating air pollution in the city. Between 2005 and 2014, the number of trips by vehicles through the 3 cross-harbor tunnels daily increased from 228,000 to more than 250,000. The reason why we're studying on ozone and nitrogen dioxide is that we're going to investigate the relationship between nitrogen dioxide with traffic flow and ozone with UV lights. Nitrogen dioxide is one of the major air pollutants in Hong Kong. Its main sources include combustion engines in vehicles and thermal power plants. During combustion, nitrogen dioxide is released into the atmosphere. However, in Hong Kong, there are no large-scale factories which involve the process of burning, such as manufacturers, and there are still at a high rate of nitrogen dioxide and ozone in Hong Kong. Why is it? This happened mainly because of Hong Kong has lots of traffic arteries which produce nitrogen dioxide.
And ozone, a secondary pollutant which is formed by reaction of sunlight, when nitrogen dioxide exposed to bright light. Oxygen molecule is first lit by electrical discharge, and one of the oxygen atoms takes into another oxygen molecule to form ozone. Ozone could be helpful or harmful, depends on the place it is found. A part of the Earth's upper atmosphere, ozone helps to protect life on the Earth by absorbing UV light from the sun, which helps reduce the risk of human having skin cancer and damaging the crops. For ozone, which is found much nearer to the ground, is mainly man-made ozone created by emission from factories and power plants, which may permanently damage the lungs or suffer from respiration infections.
So, in order to study more about the relationship between the concentration of nitrogen dioxide and ozone, we participated in the Explore project supported by Hong Kong University of Science and Technology. Air pollutants are mainly measured through this simple experimental setup. This setup consists of bolometers and air samplers assigned individually to nitrogen dioxide, ozone, and black carbon, and it also contains an air pump. The sampling method of nitrogen dioxide is as follows. Firstly, put some pieces of filter paper soaked with triethylonamine to a filter holder. Then, put the filter holder outside the window of the laboratory and collect the amount of results frequently. We collect 2 samples on Monday, Wednesday, and Friday school day, 8 a.m. rush hour and 1 p.m. non-rush hour, to extract air pollutants. Then, we use a photometer to get the concentration of nitrogen dioxide, so you can pass through the filter holder to have a look.
As you can see, the red line is the step of conducting an experiment of ozone. First, add potassium iodide into the sampling vase and wait for the bump air into it and let ozone to have a chemical reaction with potassium iodide. Then, mix potassium iodide with starch to colorize the solution. Finally, use the photometer to measure the concentration of ozone sample.
For the overall trend of nitrogen dioxide and ozone in Hong Kong, the trend of ozone in the air is increasing. From 1996 to 2014, the annual average of the concentration of ozone has increased 47%, and for the nitrogen dioxide graph showing the relationship of the concentration of nitrogen dioxide to another monitoring station in Hong Kong. The red line as shown is our school's data. In the graph, we can see that our school's data is mainly higher than another monitoring station's data. The level of nitrogen dioxide together with wind direction are plotted into a wind rows. From the wind rows, it is found that nitrogen dioxide is more concentrated in the north, northeast, and southeast of our school. Here is the map which stated the distance of different stand source network from our school. And here's the graph which shows the relationship between the nitrogen dioxide and traffic flow. We only have 4 data points due to the fact that the government has not yet updated the data of monthly traffic flow. However, we predicted that with more traffic flow, the higher the concentration of nitrogen dioxide. For another monitoring station, there are also some traffic artery of Hong Kong. So, while the nitrogen dioxide concentration is not that high, as shown in this graph, as shown in this map, you can see that the location of the monitoring station, the geographical location is similar to our school with different traffic flow surrounding. But there is an open space area with a river, so the concentration of nitrogen dioxide is weakened.
And like nitrogen dioxide with the wind growth, it is shown that ozone has a weaker relationship with wind growth than nitrogen dioxide. This is mainly because ozone is a secondary pollutant which takes time to produce in reaction with sunlight in the atmosphere. The ozone sampled at 8 a.m. on our sampling day, meaning that there is a limited time for chemical reaction with the period between sunrise and sampling. And this is the graph of ozone to another monitoring station in Hong Kong. Our school's data is much higher in the beginning and much lower recently. However, high concentration of ozone is at around 100 ppb or above. Our school and another monitoring station, concentration of ozone is low in general. For further investigation on the relationship between nitrogen dioxide and traffic flow, we will count for the amount of traffic flow daily by ourselves to avoid the data given by the government is not yet updated. And for the relationship between UV light and traffic flow, we will collect ozone in the afternoon or evening. Let ozone have a time to have chemical reaction between sunrise and the sampling time, thus have a much accurate result.
So, before the end of our presentation, our gratitude must first be expressed to Professor Lau, who gave infallible opinions on our research. His sincerity, patience, and assistance encouraged us much during the course of study. We must also thank Hong Kong Bank Foundation and the Hong Kong University of Science and Technology in providing assistance of our study. Without their help, the study could not have been completed. Last but not least, we would like to express our thanks to Mr. Jason Leung and Mr. Ming Wong, who have always encouraged us to devote fully to our study. And that's the end of our presentation. I'm Flora.
I'm Charlie. I'm Melody.
Thank you for your attention.